Hey guys, welcome back to Algos Explained. My name is David Kim, and it's been a while since I did a whiteboard video, but here we go. This is a LeetCode question. This is a LeetCode easy, so it's not going to be too difficult for today. Maximum subarray. Given an integer array nums, find the contiguous subarray which has the largest sum and return the sum. And so right off the bat, we know that our input is going to be an array of nums. You might want to ask, okay, is there any other values that might get thrown in? If they say yes, then in an interview situation, if they say yes, then you might want to error check for other values. If not, you're lucky, you don't have to worry about that. As you can see from my examples, we can get negative numbers and positive numbers, so you got to watch out for both cases. And the second part is, well, we know we have an array of numbers. We know we're working with an array data structure that's coming in, and the whole point of this algorithm is to find the contiguous subarray which has the largest sum and return the sum. And so this part here, return the sum, we just know, okay, what do they want back? We're talking about a subarray, but they don't want the subarray back, they just want the sum back. And so as we're doing some calculations within the algorithm, all we need to do is spit out the end result of a calculation versus spit out the subarray, which is, in my opinion, a little bit easier than having to return the subarray. And so what kind of subarray do we want? We want it which has the largest sum. And so here are a couple of examples. This is the one that they give us on LeetCode. But let's go over the smaller ones first. As I was solving the algorithm myself, I thought I had the solution for this guy, and then it suddenly didn't work for some of these cases. And so I wanted to go over these. And before we go over the strategy, let's just make sure we have an understanding of what we really want. And so if we want a contiguous subarray which has the largest sum, so pretty much from this array, we know what subarrays are, right? Subarrays pretty much means within an array data structure, if you just isolate the 2 by itself, that is a subarray of 2, 2, 4. If we isolate the 2 and the 2, or the 2 and the 4, that's a subarray of this array. And so we pretty much want the sum. So if we had the 2 by itself, 2 here, that sum would have been a 2. If we had the 2 and the 2, that would have been a 4, and altogether this would be an 8. And so this one, we don't necessarily take away a subarray. The whole array was pretty good, and so we took 8 from that. In this case, if we took the subarray of 1, the sum, we did it this way, the sum would have been a 1. If we took this, that would have been a negative 1 if we took the sum of the array. The whole array is considered a subarray also, and so that would have been negative 3. This is greater than negative 3, negative 1, and so that would have been our answer for this sample case. For this, of course, we already know it's going to be 3, and so let's just do that here. And so this case is the one where we get from LeetCode, and we know that the answer is going to be a 6, but let's find out why that's the case. So we need to create a subarray in which the sum equals to something the greatest we can get, and contiguous meaning we can't pick out the 1, the 4, the 2, the 1, and the 4. It has to be a continuous set of numbers. And so if we had the 2, sum would have been 2. If we got the 2 and the 1, that would have been a negative 1. The 2 and the 1 and a negative 3, that would have been a negative 4. Long story short, this is going to be our subarray that we want. And this one will equal to a 6. The 4, 2, 6, the 1 and the 1 canceling each other out. The reason why although the 1s just cancel each other out, we need to include them is because we need a continuous subarray, and if we stopped here, it would have been a 5, and so we need the 1. We don't want the negative 5 because then it'll just turn into a 1, so we would have stopped there. And so let's go over the strategy that I used to solve this question. I decided to use an iterative approach ending in an O of n time complexity. So pretty much what I like to do is I like to keep track of the head and the tail. And after I finish explaining this, try coding it. If it works out for you, great. If it doesn't, I'm also going to go through another walkthrough with the algorithm on the whiteboard and go through these cases one by one. Okay, so the way I approached it was I want to, well, there's a couple of approaches. The worst approach that you might be able to take is getting every single subarray. We don't want to do that ever. Meaning, say someone got like -2 and determined the sum was that. If they got -2 and 1, determined the sum was that. -2, 1, -3, and determined the sum was this. And then did it for 2 and all the numbers, and then did it for 1 and all the numbers, did it for -3 and all the numbers. That would give you every single sum possible of every single subarray at the same time. And then you could just compare all those sums and you would have ended up with 6. But that is the worst thing you can do. And so let's go ahead, and the beauty of working with arrays is that we have indexes, and indexes is a very powerful tool in terms of being able to slice up your data structure, or well, if it's an array, if it's an array data structure. And so what we're going to do is we're going to keep track of 2 pointers because we want some kind of subarray within an array. And so how do we know if it's a subarray? We need to know where the subarray starts. We need to know where the subarray ends, and then we need to keep track of the max max sum. And then as we're moving the pointers, we want to create a new sum and then compare that to the max sum. And I know on LeetCode there have been different solutions. I finished mine, submitted mine, got the performance, and then looked at the other solutions. And then I copied and pasted the other solutions and I ran it again, but it ended up being the same performance-wise. And so, okay, so we're gonna hold on to a head. And then, actually, yeah, let's spell it out. We know that we're gonna have a max, and then we're gonna have a new max, and then we're gonna have a head, and we're gonna have a tail. Okay, maybe I'll be over here. And so let's go ahead and pretend the head is here, the tail is here. And so these are gonna represent values. Later when we're gonna write the code, we're going to represent the head and the tail as indices. But once you see the code written out, it'll be very easy. We're just using this for our case so that we can visually see it better. In code, it's very easy to represent this head as the value, because if you hold on to the indexes, you could just do array of the index head, and then that'll be the value itself. New max, we're gonna set it all to -2. And another thing that, one thing that I didn't write on here that is on LeetCode is that you're guaranteed a number. And so luckily for us, we can just initiate it all as the argument of 0 index. So say if in our parameter we were given nums of 0, we could initiate it all to that. Again, we'll see that in the algorithm later, but if you're getting this in an interview situation, you definitely want to ask your interviewer everything you can about what can possibly throw you off in the parameters. All right, so here we have the head and the tail. And so what I want to do is kind of imagine our subarray right now is looking like this. It's a 2. And the sum of that, we have it here as a -2. The head is at the 0th index, and we're just going to represent it at the value stage. And so what are we going to do? We're going to move the tail, and see what happens. And so the tail is at a 1 now. And so we automatically, let's update this new max, which will be at a -1. And so we say, okay, is the tail greater than the new max? And if it is, then you might think, okay, let's go ahead and update the head, because dragging on, so if we want our new subarray to be this, well, we technically don't need the 2. We could exclude it here because it's just dead weight. It's just being negative to us. And so how do we determine that? We determine it through this portion right here. Once we have the new tail, is that greater than the new max after the new max has been updated? And it's important to check it after the new max has been updated. And we'll see in the other cases why. And so once we have the tail, we check the new max. Okay, since it was greater than, let's go ahead and update the head also. And so the head will be at a 1, and this one will also have updated everything to a 1. And so that would have been a special case in the for loop where we're not going to see the jump every single time. And so when it does, though, everything updates at the same time. So here's a regular jump that happens. Let's go ahead and move the t over to a -3. We're going to update the new max. And so this is going to be a -2. Now we're working with our subarray that looks like this. This is our subarray right here. And is -3 greater than that? It's not, so there's no purpose in trying to do an auto jump all the way to the -3. And let's see, we're creating a subarray, so would excluding the 1 help us out? We could do that by checking head minus this. Would it be greater than the max? No, it's not. And so we're going to leave head where it is. And so now we're just going to move the t here for the 4. All right, and so we're going to update this automatically. We're at the 2, and so we'll see again. This looks like we should probably auto jump again. And so let's check our logic here. 4, is that greater than the 2? The updated 2, and it is. And so let's do an auto jump. The head gets moved over here. Everything pretty much gets moved. And the reason why new max and max is that is because head has become the same as the tail, which pretty much means that our subarray is now a single value subarray at that index, meaning this is our subarray that we're going to calculate our sum for. And so let's go ahead with the normal calculations. Our tail value is -1. Let's update this at that's a 3 now. Should we auto jump everything to that? 1, is that greater than that? No, it's not. Is it worth moving the head? 4 minus 3, is it greater than 4? No, it's not. And so let's go ahead and just move the t. And this is our subarray. We wanted to have updated that to a 5. And I want to get in the way here. And so we just updated that. Do we want to auto jump all the way to the 2? Is that greater than? No, it's not. Okay. Is moving the head going to help? No, it's not. And we should have updated this. And so that's going to be a 5. All right, let's move the t again. The tail value is going to be at a 1. And I might be out of the frame, but you can still hear me. This is going to update to a 6, and we know that that's kind of where we're going to end, but we're going to go through the whole thing. Should we auto jump to 1? No, we are not going to do that. And 5 up, the max updates to a 6. Will bringing in the head help us out? 4 or 6 minus the 4. That is not going to be greater than the 6 max here, so we're not going to do that. And I forgot to have updated this. And I totally did that wrong there. The -3 should have never been there. -1 and 2, and we just finished the 1. Okay. And so that is our current subarray, but we're definitely adding more to our max calculation, so let's keep that open. We're going to move the t here. It's going to be a 5, or it's going to be a -5 value. Update this to a 1. And because we technically added the -5 in there. But let's see. Should we auto jump to the 5? Of course not. -5 is less than 1. And will moving the head in help it out? And when I say moving the head in, you understand that we want to adjust our subarray, but at the same time, how we calculate that is our max minus the 4, because we're going to have been including the 4, and we're going to now exclude it. So that's why we're taking the new max minus the head value, and that's not going to help us out. So we're going to leave the head where it is, and we're going to see, how about this 4? So tail is here, and see how if I had checked against 4 to see if we should have auto jumped, we might think, okay, we should auto jump here because the 4 is greater than the 1. That is exactly why you need to update the new max first and then check it. This is not a case for auto jump because we have a greater value, and therefore we know don't auto jump from, we had this good bit right here. When we had this, we had a 6. And notice that we never changed our max, although this calculated subarray has been increasing. Now we have considered the 4, and now our new max. So pretty much this is this over here. This is this. And 5 doesn't have to, well, it doesn't get to update the max. Moving into 4 would have not done anything either, so we keep the 6. Okay. So since we got that out of the way, we kind of have an idea. We're going to have a for loop that iterates through this entire array. And notice how we didn't have to do it twice or several times at all. We just had to do it once while we kept track of the head and tail values. And in our example, we kept track of the values just for the ease of explaining the problem. But in our algorithm, we're going to keep track of the indexes just because incrementing the positions of head and tail by like plus or something like that is a lot easier than trying to figure out what value it used to be. So the key things here is we took our argument and we were able to do it in one go, thanks to keeping track of the head and the tail, and thanks to having a max that we always held on to and never updated unless there was something better, and also a new max that we, although at one point it was good, we kept on updating it just to see if maybe there was something better out there. And okay, cool. So now we're going to write the algorithm down and we're going to run over some of the smaller cases. All right, guys, we're back here with the algorithm, and definitely lengthier than the ones that you can see on LeetCode. After you've submitted an answer, you can go to details and look at what other people have submitted. And it's definitely lengthier, but I think it's the best way to really explain what's going on with this question. So here we go. We're going to do a walkthrough of this, and I'm going to be out of your way in case you just want to look at it on your own and try to solve it or digest it. But what happened here was, like we said, we're going to hold on to a head and a tail, and I guess I could have called these head index, tail index, because that's what they're representing. Here, max and new max, we're all initiating at the 0th index, meaning if we have an example here, we're starting at the first value. Okay, so we initiated that, and then we're gonna see how this for loop, it goes through all the way down here, and then, so that is that if. That's the for loop, that's the function, and at the end we return max, but pretty much all the logic we did is within this one for loop. And so what happened is nothing special going on in here. We're just going to go through that, and actually I'm going to change this where it is, we're going to start at 1 because we don't need to, we already have the 0th value, so we can just start at 1. So the tail is going to be initiated pretty much to I, and so this is going to be the first iteration, whereas in an example, the head and the tail were at the 2. This is the first move of the tail. And so the tail is initiated to that index of I. Here, the new max is updated because, like we said, we want to update the new max first, and then we want to compare it. And so here it says if nums of tail is greater than new max, then we're going to, this is the auto jump. This is the auto jump where we see that we've been holding on to dead weight. Although it looks like good dead weight, we're letting go of it all. And so head is going to jump all the way to where I is. And then max is going to be updated only if it is actually greater than the value of the tail value. And I believe this is covered in one of the cases that I've written down here. But without this statement here, if we were to automatically update max to just be nums of tail versus checking to see if the max was actually better than that or not, we're not going to be able to solve for every case. New max, of course, is going to be updated again. So pretty much, other than this piece of code that I actually didn't talk about previously, everything is the same. We're automatically jumping, and therefore the head is reinitialized to I. New max is at the tail again, and we're going to actually continue because we don't want the rest of this code. We want to go back to the for loop and just move on with the I. If we didn't do the auto jump, we are going to go down here and 2 if statements. Very simple what's going on here. New max, is that greater than the max? And so pretty much, this is pretty much updating the max because we want to always hold on to the best value. Whether new max pushes forward with or without us, we know that max is going to just hold on to the best one, And so this is just doing that logic here. It could have been turned into like a ternary statement, very short, but it's an if statement here, meaning this is where, okay, do we want to push the head in also? And notice how we use plus plus and we're not making head equal to the I. It's because maybe the tail, which always kind of represents where the I of this for loop is, maybe the tail grew really long and we don't want the head to go to the tail because then that'd be an auto jump essentially. We want the head to increment slowly inwards if it benefits the max. And in this case, we check if it benefits the new max by saying, if we take the new max and we remove the head, is it going to be better than the max? And if it is, then we're going to do it. If it's not, we're not going to move the head. And that would be the only time, these would be the only times when the head moves, whether it benefits to squish it in by 1 or when we're doing an auto jump. And so those are the two cases where the head moves. Tail is always moving. Tail is moving with the for loop. And so let's go ahead and then of course at the end, we're going to return the max value. One thing that I feel like this algorithm doesn't cover, or maybe I didn't do too well, is helper functions. Maybe this could have been a helper function. Maybe every single component of this could have been a helper function. I don't know. It seemed kind of too simple to break it out, but at the same time, I don't want to go through another algorithm video without mentioning use helper functions for everything you do because they are immensely helpful. They save time, and yeah, it's just one of the things that I didn't know that I feel like changed the game for me once I did realize it is a must. It is not just a helpful thing to do, it's a must. And of course, not a must in every single situation because sometimes the question is going to be easy, but when you know you can, you must do it. All right, so let's go over these questions here. All right, we'll do the easy ones right over here. So 2 to 4. And of course, if you already understand everything, thank you for watching. But I'm going to do this. I'm going to do the easy ones. Hopefully, we're going to run into why this statement here, this ternary, is important. And then at the very end, we might even do the long one again. And I'll make another announcement before I do that. Not a special announcement, just letting you know. Anyways, the head, we're going to try to do this fast now because we have the answer already. Head to tail, we're just going to go through it. Let's see that. This is, of course, like I said already, it's the indexes, but we're going to work with values when we're going to run through the example. And so we're going to work with max, new max, the head, and the tail. Okay, so everything is at a 2 because, again, values, you could just consider nums of 0. And you can see why we did indexes versus values because of cases like this. Head plus plus, that's just so much easier. And converting these head indexes to values like nums of tail is just too easy, but it's really hard to do it the other way back. Okay, so at the very beginning, max is the initial value of 0 as index, so it's 2. And so we're gonna go here. We're starting at the index of 1 where the tail is, and so tail becomes a 2. And then we see, okay, first thing we did was we update the new max, that's the 4, and we say, should we auto jump? Auto jump, auto jump here. Should we do it? No, we shouldn't. And let's see. It's taken care of by this. And if we had not, or well, since it's the greater than case, I guess we would have not jumped anyways, but we wouldn't jump and then we check is this, and so we're going to update this. And so this is just update max. And then we're going to say, okay, should we increment the head? Should we move this one in? And why would we do that? Well, we could see, okay, 4, if this is essentially our subarray, and if we lost the 2, that would be the 4 minus the 2. Would it benefit us? No, it wouldn't. And so this is head, let's see, head move. Okay, that's what that represents. And so we don't move the head. We kept the 2, we kept that. Tail moved again. So now it held the value of 4, new max of 8. We didn't auto jump. Update the max, we update that. Head, will the head move? No, it wouldn't. And so we're left with the 8 at the very end because we're done going through the for loop. All right, got that. So now we do -1 and 2. Tail, max, new max, the head and the tail. All right, so we are going to, this is a -1, everything is a -1. The tail moves, and this was also a -2 here. The tail moves, and let's see. This is now -2. New max is a -3 now because -2 plus -1. And so we say, should we do an auto jump? And so this, is this less or is this greater than this? And it actually is. Let's see. So nums of tail, it is. And so we go ahead and auto jump. And so head becomes this over here. So the value of this is -2. And max, so now we're going to check the max. So this is a case where this ternary makes sense. In the end, we know that the answer is going to be a -1. But if we had just changed the max to equal the nums of tails, which is this currently, this would have changed to a -2 and given us the false answer. However, we do this check just to make sure, okay, the max we got right now, is that better than what we're trying to change it to right now with the auto jump? And with that comparison, we know that -1 is greater than -2. Therefore, we're going to hold on to the max, this one. And so we're going to keep that where it is. And new max is going to change to that value because we did an auto jump. And essentially, we're looking at this subarray now. And then we're at the end of the loop. And so we exit out. And since our max is the value we care about, we hold on to that, we return that. And you might be thinking, okay, why then did we even auto jump at all? Why did this even let us auto jump? Well, the fact that it let us auto jump is because this was essentially dead weight. Maybe something better came over here, like maybe there was going to be a 5 here. We don't want to hold on to the -1, and so we did want to lose the dead weight. Auto jump is AKA for losing dead weight, losing any negative numbers, anything negative. And so we did definitely want to lose it. We just didn't want to update the max because that was currently the best we had. We didn't know if it was just going to constantly be negative, then we want to constantly be auto jumping. But we still want to hold on to what the best we had at one point was. And so that's why this line of code is essential. And before I had that, this case failed for me. All right, guys, so this is the last of the little ones. I had to do a retake, that's why it's a little different. But this is the example that's going to explain why we want to calculate the new max before we do the auto jump check. And so let's initialize all of our values. Value for head and tail are going to be a 1 at the first index. At the 0th index, which is the first one, max and new max are going to be the first value also. And we're going to go ahead and move the t. And so the t value, the tail value, changes to a 2. And so initially, before I had that there, my logic was, okay, is this new value better than what I've had before? And that made sense if everything you had before was negative. But what if before what you had was positive? In this case, it was positive. We don't want to treat a positive number like it's dead weight. And so, but imagine we took out this line of code, nums of tail is that greater than new max. In this case right now, before we had updated it, we would have considered that to be an auto jump worthy situation. We don't want to do that. And so therefore, simple fix, we just need to update this guy first, the new max. And so now we check and no, we don't want to auto jump and we know that. And so we go ahead and continue with the code. We skip that, update the max to 3, and the head is not going to get subtracted, or it's not going to get pushed in. We end up returning the 3. Okay, cool. And so that was this algorithm. The other cases that I had, the smaller cases, you could actually solve for that big example that's on LeetCode and still get the algorithm wrong due to these tiny little cases, which happened for me, and I did it a couple times. The video is getting long, and so I'm not gonna go over the big one again just because I did it before in the walkthrough. Hopefully you understand or have a better idea of this problem. And so if you like the video, be sure to like, comment, subscribe, and I'll catch you in the next one. Bye.